In this video, we are going to do some additional practice on molar conversions. So these are just examples. I will do a few examples in each of the sections. The thing to remember overall with these conversions is we said we always have to go through the mole. So we could be going from grams to moles, or moles to molecules and atoms, right? The conversion from moles to molecules or atoms is our Avogadro's number, isn't it? 6.022 times 10 to the 23rd atoms or molecules, and that's per 1 mole. To go from moles to grams, we would use the molar mass, right? Which has the units of grams per 1 mole. Okay, so always start with the given value, right? Set up the T-chart, and last but not least, make sure units cancel. That's the all-time most important thing. So let's first try this. We are going to determine the number of moles of each element in the following. So this is where we were counting atoms, wasn't it? So first, if we have 1 mole of NH3, right? How many moles of each element did we have? Well, we have 1 nitrogen atom in this molecule, so for every 1 mole of NH3, we'll have 1 mole of nitrogen, won't we? And then for every 1 mole of NH3, we'll actually have 3 moles of hydrogen. These would be the conversion factors we'd use. So let's put our given 3 moles NH3. First I'm going to figure out the number of moles of nitrogen. Okay, set up my T-chart. Well, I need to get to moles of nitrogen. So I will use this conversion factor. This unit comes down so it cancels. So on the bottom will be moles NH3. In the numerator there will be moles of nitrogen. This happens to be a 1-to-1 ratio. So if we do the math, for every 3 moles of NH3, we have 3 moles of nitrogen. All right, next let's look at hydrogen. What's our given? 3 moles of NH3. Set up the T-chart. For this unit to cancel, it's got to drop down. Moles of NH3, and we want to get to moles of hydrogen. I'm going to use this conversion factor. 1 mole of NH3 gives me 3 moles of hydrogen. Alright, units cancel. I'm left with moles of hydrogen. And guess what? For every 3 moles of ammonia, I have 9 moles of hydrogen. This has to do with us really just counting the atoms in the molecule and applying that to moles. Okay? I'm going to erase this as well as I can, and we'll try the next one. Let's try this. Let's do the 5 moles of H2SO4. Well, let's write our conversion factors. For every 1 mole of H2SO4, which is sulfuric acid, how many moles of hydrogen would I have? Well, there's 2 atoms, so for 1 mole of sulfuric acid, I'll have 2 moles of hydrogen, won't I? For 1 mole of sulfuric acid, I have 1 sulfur atom in there. I'll have 1 mole of sulfur. And for every 1 mole of sulfuric acid, notice I have 4 oxygens here, so I'll have 4 moles of oxygen. Okay, so we're starting with 5.0. Notice 2 sig figs, 5.0 moles H2 SO4. Let's find hydrogen first. Okay, set up our T-chart. Well, I need this unit to cancel. It's going to come down here, moles of H2SO4, and I want to get to moles of hydrogen. So I'll use this, flipped over, right, the reciprocal. For every 1 mole of SO4, I have 2 moles of hydrogen. Okay. Alright, if I do the math, I end up with 10 moles of hydrogen. 2 sig figs. 2 sig figs, I'll have to put a decimal point there to get 2 sig figs on the hydrogen. Sulfur is 1 to 1, so instead let's take oxygen. Okay, we're starting with 5.0 moles of sulfuric acid. That's my given. Set up my T-chart and get my units to cancel. For this unit to cancel, it's got to come down to the denominator, doesn't it? H2SO4. And I want to get 2 moles of oxygen. So I'll use this conversion factor, the reciprocal of it. 1 mole of H2SO4 is 4 moles of oxygen. I do the math, I end up with 20. I put a decimal point to get 2 sig figs, and that's how many moles of oxygen are in 5 moles of sulfuric acid. Right, let's move on to the next type of problem. Determine the number of moles in the following. So here, we're starting with grams, and we're going to move to moles. This is where we use our molar mass. So the first one I will do is, I'm going to start with 100 decimal point grams of this sulfuric acid. Alright? This is my given. I set up my T-chart. I want to get 2 moles of H2SO4. That's got to be in the numerator here, doesn't it? And this unit has to cancel. It's got to drop down, or this will never work. Okay? Remember, molar mass is always grams per 1 mole. We never have a number other than 1 mole when we're dealing with molar mass. So I have calculated the molar mass of sulfuric acid, and it turns out to be 98.03. Now, we did figure out how to calculate, though. That's for another lesson. But if I do the math here, notice 3 sig figs. I do the math, it's 100 divided by 98.03. And if I'm going to have 3 sig figs, my answer will be 1.02 moles of H2SO4. Next, let's try this one. 59.1 grams of CHCl3. Write my given, set up my T-chart. I want to get to moles of CHCl3. That's got to be in my numerator, folks. And this unit's got to cancel. It's coming down here. Molar mass is always some number of grams per 1 mole. So I have calculated the molar mass of this compound, and it is 119.37. Notice, 3 sig figs. So my answer needs to have 3 sig figs. So 59.1, it'll be divided by this 19.37, and my answer with 3 sig figs looks like this, 0.495 moles of CHCl3. Moving on. Now we're going from moles back to grams. Again, we're using molar mass. So let's just do one of these, okay? I'm going to start here. What am I given? 1.91 times 10 to the negative 3 moles of C6H6. Given T-chart. All right. I want to get 2 grams of C6H6. That unit had better be in my numerator. And this unit needs to cancel. It drops down here. Molar mass is always per 1 mole. And I did figure out the molar mass of this. And that's my number here. 3 sig figs 3.91 times 10 to the negative third times 78.12 equals, with 3 sig fig, my answer looks like this, 0.149 grams C6H6. Alright, last type. Here, we're going from grams all the way through mole, all the way to molecules or atoms, right? This is what we call a two-stepper. So let's pick one to do. Start with this one. 6.37 grams carbon monoxide. Well, I have to get to mole. And what did I use? I used molar mass. Well, grams have to drop down in order to cancel. Then I'll get to 1 mole of this. The molar mass is 28.01. So notice I've gone from grams to moles of CO. But now I need to go from moles to molecules. And that's my Avogadro's number. Molecules had better be in my numerator here. 6.022 times 10 to the 23rd molecules in 1 mole of carbon monoxide or whatever you have. Okay, do the math. Now, I'm noticing that people are writing their answers. 3 sig figs, so here are my 3 sig figs. But they're missing times 10 to the 23rd. Always look all the way right in that number in order to make sure you're not missing that. Okay? 1.37 doesn't make sense. We don't have 1.37 molecules. We have 1.37 times 10 to the 23rd. Alright, now let's do this second one here. What's my given? 2.62 times 10 to the negative 6 moles. Oh, here are moles of H2O. So we're going from moles. Great, we're at moles. We're moving the molecules. So the only thing we have to worry about is Avogadro's number. But since I want molecules of H2O as my answer, that unit had better be in the denominator right here. And this unit had better slide down here so that it will cancel. Well, Avogadro's number tells me for every 1 mole of water, I have 6.022 times 10 to the 23rd. So let's do the math here. So this number times 6.022 times 10 to the 23rd equals 1, I have what? 3 sig figs, 1.58 times 10 to the 18 molecules of water, right? These units canceled. I was left with this. So you can see why the units I need in my answer had better be in the numerator of that last conversion. Okay? Or it will not work. Let me see if I can quickly do one more of these. Let's start with 15.4 grams of bromine, one of our diatomic molecules. It's a two-stepper, and I need to have molecules be in the numerator here so that it's in my answer. Alright, so 6.022 times 10 to the 23rd molecules in 1 mole. We're going to have grams of bromine in 1 mole of bromine. So I need to quickly look at my periodic table, if I have it handy, figure out what bromine is. 79.91. Okay, whoops. So it's times 2, right? 79.91 times 2, which is 159.82. 3 sig figs, 15.4 times 6.022 times 10 to the 23rd divided by 159.82. 3 sig figs, 5.8. Let's go back, sorry. 0.80 times 10 to the 22nd molecules. All right, thank you very much.